Some mysteries are fake. Some are already solved. And some are real enough that scientists are still arguing over the actual evidence right now. This list is about the third kind, documented phenomena with serious data behind them, where the answer is incomplete, disputed, or still out of reach. No invented aliens. No fake artifacts. No miracle claims. Just 10 real questions from physics, astronomy, earth science, and official government investigations. Ranked from strange to genuinely universe-sized. Number 10 begins with a sound that only some people can even hear. Number 10, the hum no one has traced. Since the 1990s, a persistent low-frequency hum has been reported in Taos, New Mexico, and later in dozens of other locations worldwide, from Bristol, England to Windsor, Ontario. Only a minority of people in each area report hearing it at all. Researchers, including teams from Los Alamos National Laboratory, have investigated specific cases and ruled out some local sources in some locations. But no single confirmed external source explains every report. Possible explanations include distant industrial noise, low-frequency environmental sound, tinnitus, and genuine differences in individual hearing sensitivity. The mystery isn't one hidden global machine humming somewhere underground. It's why similar low-frequency reports keep appearing in unconnected places worldwide, and why only some people perceive them at all. Number 9, ball lightning. For centuries, eyewitnesses have described glowing, floating spheres of light appearing during thunderstorms, sometimes drifting through walls or closed windows before vanishing or violently exploding. For most of scientific history, it was treated as folklore, or dismissed as a trick of human perception. In 2014, a Chinese research team studying an actual thunderstorm captured a natural ball lightning-like event on video and spectrograph simultaneously, one of the strongest instrument-recorded observations of the phenomenon to date, published in the journal Physical Review Letters. That single event doesn't prove every historical account described the exact same thing, but it confirms something real physically happens. What actually generates it remains genuinely debated among physicists today, with multiple competing models and no single confirmed mechanism. Number 8, the Great Attractor and the Zone of Avoidance. The Milky Way and our surrounding galaxies move through space in a direction that doesn't match a simple, uniform universe, a motion first inferred from the large-scale flow of galaxies decades ago. Astronomers named the apparent destination the Great Attractor. Much of that region sits directly behind the dense plane of our own galaxy, an area astronomers call the Zone of Avoidance, where dust and stars block a clear observational view. Later surveys have revealed real structures there, including the Norma cluster, situated within the even larger Laniakea supercluster context that our own galaxy belongs to. The mystery isn't whether gravity is acting on this scale. It's how the mass concentrations hidden behind our own galactic plane actually fit together to fully explain the flow. Number 7, the WOW signal. On August 15, 1977, Ohio State University's Big Ear radio telescope detected a narrowband, unusually strong radio signal arriving from deep space. It was distinctive enough that astronomer Jerry Ehrman circled it on the printout and wrote one word beside it: wow. It became a classic SETI candidate signal precisely because of its strength and its very specific, narrow frequency, close to a frequency scientists consider a natural place to listen. But it never repeated, not in follow-up searches conducted at the time, and not across decades of searches since, using far more sensitive instruments. Without a second detection, no explanation, natural, human-made, or artificial, has ever been confirmed. It remains exactly what it was in 1977, real, recorded, and unrepeated. Number 6, the Hubble Tension. Two of the best methods scientists have for measuring how fast the universe is expanding keep giving different answers. Measurements based on the early universe and the cosmic microwave background, led by the Planck satellite, produce one expansion rate. Measurements based on the nearby universe, built from Cepheid stars and supernovae in a project called SH0ES, produce a noticeably higher one. The gap isn't enormous, but it has survived years of improved data, including cross-checks using the James Webb Space Telescope, which confirmed the nearby measurement rather than resolving the discrepancy the way many scientists initially hoped it would. Either one of these two measurement chains still hides an unidentified systematic error, or our standard model of cosmology is quietly missing something important. Number 5. Fast radio bursts. These are intense flashes of radio energy from deep space lasting only milliseconds, some releasing more energy than the Sun produces in days. Thousands have now been catalogued, largely by the Chine telescope in Canada. In 2020, astronomers finally traced one to a specific, confirmed source, a magnetar, a type of ultra-dense neutron star, located inside our own galaxy, detected simultaneously by multiple observatories. That was a major breakthrough for the field. But most fast radio bursts detected in other, more distant galaxies still lack any confirmed source, and some repeat on no predictable pattern while others never repeat at all. The mystery isn't whether fast radio bursts are real anymore. It's whether one single mechanism explains all of them, or whether the universe is producing similar radio flashes through several genuinely different processes. Number 4. The Muon G2 tension. For years, Fermilab's precise measurement of a subatomic particle's magnetic behavior appeared to disagree sharply with older, data-driven theoretical predictions, a gap that fueled real excitement about undiscovered physics hiding just beyond reach. On June 3, 2025, Fermilab released its final, most precise result yet, accurate to 127 parts per billion, the culmination of 6 years of data collection. At almost the same time, theorists using newer lattice QCD calculations released an updated standard model prediction that shifted significantly, and now largely agrees with the experimental result. The experiment itself isn't seriously in question anymore, it's extraordinarily precise. What's still unresolved sits entirely on the theory side: which calculation method, the older data-driven approach or the newer lattice approach, actually gives the correct prediction. Until that theoretical disagreement is settled, the door for genuinely new physics stays narrowly, honestly open. Number 3. Ultra-high-energy cosmic rays. Occasionally, Earth is struck by a single subatomic particle carrying more energy than anything humanity's largest particle accelerators can currently produce. In 1991, one such particle was nicknamed the Oh My God particle. In 2023, the Telescope Array Observatory detected another, nicknamed the Amaterasu particle, at roughly 244 exaelectronvolts. Charged particles like these don't travel in neat straight lines through space. Magnetic fields scattered across the galaxy bend their paths unpredictably, erasing any clean trail back to their original source. Candidate sources include active galactic nuclei, gamma-ray bursts, and starburst galaxies, but no single confirmed accelerator has ever been definitively matched to these very highest energy events. The particles themselves are real. Their energies are measured with real precision. The cosmic engines producing them remain genuinely unidentified. Number 2. Dark matter. About 85% of all the matter in the universe appears to be dark matter, meaning it doesn't emit, absorb, or reflect any light whatsoever. That's not 85% of everything. Dark energy makes up a separate, considerably larger share of the universe's total mass energy budget, alongside a much smaller remaining slice of ordinary, familiar matter. The evidence for dark matter's existence is overwhelming, and comes from multiple independent sources: galaxy rotation curves, gravitational lensing around massive clusters, and the cosmic microwave background all point firmly in the same direction. What's still missing is direct detection. Major underground experiments, including XENONNT, LZ, and PandaX, have spent years searching directly for an actual dark matter particle. So far, none of them has found one. Number 1. Officially unresolved UAP cases. In April 2020, the Pentagon officially released 3 military videos, code-named Gimbal, Go Fast, and Fleur 1, confirming they were genuine, unaltered footage from real Navy pilot encounters. Since then, the government's own review has continued to move forward. In a report dated February 2025, the All-Domain Anomaly Resolution Office concluded that the Go-Fast object showed no anomalous flight characteristics once altitude and wind data were properly accounted for, most likely a small, ordinary airborne object, not an unresolved mystery. Gimbal and Fleur 1 remain listed differently in the current record. The 2021 preliminary government assessment found most cases within that specific early dataset unexplained at the time. Later AARO reporting has since resolved many newer reports through balloons, drones, and other genuinely mundane causes. The real, narrower question today isn't whether the Pentagon has unexplained files somewhere. It's what actually remains after every ordinary explanation has been carefully removed. 10 real questions, from a hum in New Mexico to particles crashing into our atmosphere with impossible energy. Some have partial explanations already. Some genuinely don't have any yet. That's not a failure of science, and it isn't proof of anything supernatural either. Unresolved means the evidence is incomplete, disputed, or still under active investigation, nothing more, and nothing less. Which of these do you think gets explained first? Subscribe if you want to keep following the questions that don't have clean answers. See you in the dark.